So, lesson 2 basic differentiation rules and rates of change. So, started working with derivatives last time. We're going to completely take the next step and go in another direction with differentiation. I think you're going to like. But first, to kick off in the old way. So, f of x equals x to the third plus 2x. We replace this with the limit as change of x goes to 0 of x to the third is going to become x plus change of x to the third plus 2 times x plus change of x. Minus the original, so minus x to the third minus 2x all over a change of x. Now this first one, you would FOIL it out, and I'm going to take the shortcut here because we have a little bit of space here. So what this is going to go to is this is x to the third plus 3x squared change of x plus 3x change of x squared plus change of x cubed. We're going to distribute the 2 in there, so plus 2x plus 2 change of x minus x to the third minus 2x all over change of x. So we can start reducing some things. So minus 2x plus 2x minus x to the third plus x to the third. So the only thing we have left should have a change of x in it. So 3x squared change of x plus 3x change of x squared plus a change of x cubed plus 2 change of x. And again, this is all over a change of x. So we can reduce now. So it's going to cancel the one that's there, cancel one of these to make this 2, and cancel that one there. So what we have left is the limit as change of x goes to 0 of 3x squared plus 3x change of x plus change of x squared plus 2, and there is nothing on the bottom, sorry. So as change of x goes to 0, that means this one's gone and this one's gone, and we're left with 3x squared plus 2. Now, what we're going to get into next is really the shortcut way of going from this to here without doing all of this. So, theorem 2.2, the constant rule. The derivative of any constant is 0. So, any number that's a constant that doesn't have a variable with it, when you do the derivative, it's going to be 0. So if we did the derivative of, say, 4, derivative is 0. The other part of this, and this is going to be your favorite thing, is the power rule. Power rule is this. We take whatever the exponent is, it moves in front, and we subtract 1 from the exponent. So if you come up here, we take the 3, put it in front, we subtract 1 to make this 2, 3x squared. 2x is technically x to the first, so we bring the 1 in here. 1 times 2 is 2. But x to the 0 would be 1, so we just have the 2, the x is gone. That's where this is coming from. So we have problems like this. So x to the third, the derivative, we bring the 3 in front, subtract 1 from the exponent, and we're now 3x squared. Now, with this, we're actually going to rewrite this as x to the 1/3. Because with roots is always at the bottom, the powers go to the top on the exponent. So then we can do power rule with it, and it becomes 1/3 x to the negative 2/3. Or you might see this written as 1 over 3x to the 2/3, because we don't like negative in the exponents. If we have this here, again, we're going to rewrite this as x to the negative second so that we can write y prime as, well, we bring that in front, so minus 2x. Subtracting 1 there would make this negative 3, because negative 2 minus 1, negative 3. And so it ended up being negative 2 over x to the third. So much easier, so much nicer. But we do it this way first so that you appreciate being able to do this and you see where all this came from. So again, people were doing this way and they're like, wait a minute, I see what's going on here. Let's keep doing all this and we can just do power rule and get this. And then they came up with power rules. So we're going to find the slope of the graph f of x equals x to the fourth for when x is negative 1, x is 0, and x is 1. So finding the derivative gives you that equation to find the slope at that particular x. So first off, derivative of x to the fourth. Instead of doing the quotient rule, not the quotient rule, the difference quotient, power rule says this is going to go to 4x to the third. Because again, the 4, the exponent in that third, comes to the front, and we subtract 1 to get the new exponent. So now we're going to do f prime of negative 1, f prime of 0, f prime of 1. So if I put 1 in here, negative 1. Negative 1 to the third is still negative 1. Negative 1 times 4 would equal a negative 4. 0. 0 cubed is still 0. 0 times 4 is still going to be 0. And 1 in there, 1 cubed is 1. 1 times 4, we get 4. So we have our slopes, we have our derivative, lickety split, that easy. Now, they may want you to find the equation of a tangent line with the graph of f of x equals x squared, or x equals negative 2. So what they're saying is this. At that point, when x is negative 2, it wants to know what would the equation of the line be that represents the slope at that spot. So first off, we need to find this point. To find the point, we're going to do f of negative 2. Put the x in, get the y out, just like you've been doing for a long time with math. So f of negative 2 squared would be 4. So our point is going to be at negative 2, 4. To find slope, find the derivative. It'll give you the slope equation. So it's x squared, so it becomes 2x. 2 minus 1 is going to be 1, so just 2x. So now we can do f prime of negative 2. So in other words, 2 times negative 2, and we get negative 4 then for our slope. So our equation, if you remember right, point slope form is y minus y1 equals m parentheses x minus x1. So x1, y1 our point, m is our slope, so y minus y, so 4, equals our slope, negative 4, parentheses x minus a negative 2, which makes it plus 2. And there's your equation. Now, as long as it doesn't say write the equation in slope-intercept form, this is good. If you do need the slope-intercept form, you just solve for y. So distribute the negative 4 in, and you'd have y minus 4 equaling, let's slide this up, negative 4x minus 8, add the 4. So y would equal negative 4x minus 4. Theorem 2.4, which is the constant multiple rule. So what this is really saying is, if you have a number times your variable, you're just going to do the derivative of whatever that variable is, that term, and you're times it by whatever number was in front. So if we have 2x to the third, so when we do the derivative, we would take the 3 and move it in front. Well, there's already 2, so 3 times 2 makes this 6, and then x, we subtract 1 squared. So the 3 still comes in front, but because there's already 2, we're going to times by what's there. So 3 times 2 gives us our 6. X to the third, we subtract 1, make it x squared. Here, remember, if it's to this root, we're really saying 3x to the 1/3. So when we do our g prime, one third comes in front. One third of 3 is just 1. And we subtract 1 to make it minus 2/3. So in other words, 1 over x to the 2/3. So 1/3 of 3 is 1. 1 times itself. Or 1 times anything is itself. So last one here. Okay, I'm going to rewrite this so it's 4x to the negative second. And we'll make it 4/5. We'll go that route. So when we bring the 2 in front, that's going to times by the negative 4. So y prime would equal negative 8/5 x to the negative third. So in other words, negative 8 over 5x to the third. So, questions there. Let me know if you had them. Again, just still doing power rule, just whatever exponent's there, you're going to times it by whatever's in front. When you bring it down, subtract 1, just like you're doing before. Now, like I say here, be careful to parentheses. 2x to the third and 2x to the third, totally different things. Yeah, you can be careful about it. This, we can go ahead and do the derivative. That goes to 6x squared. Here, you'd have to distribute the 3 in, which would make this 8x to the third, and then do the derivative of it. So careful with that. Now, sum and difference rules is really just saying that, hey, if you have functions that are added together, you just do the individual derivatives and then you add them together. Subtraction, same thing. So this is where when we have multiple, what's the right word I'm saying? Multiple terms, we're just going to do the power rule with each one and we move on. So f prime of x. Derivative of x to the third, 3x squared. Bring the 3 in front, subtract 1 from 3, we got that. Minus, well, this is technically x to the first, so 1 times the negative 4 is still negative 4. The x, when you subtract 1, will be x to the 0, which is 1, so the x disappears. And any constant is 0, so that's it. That's all we got to do. For this next one here, so again, x to the fourth. You bring the 4 down, 4 over 2 would make this 2. So negative 2x, if it was to the fourth, when we subtract 1, that makes it to the third. The next one, 3 down would make this plus 9x, subtract 1 from it, squared. Minus the 2, again, this is technically the first, so 1 times 2 is still 2. X, when we subtract 1, would make the x to the 0, which is just 1, so there we go. So really what's happening here is we're losing an x in each term, and that exponent is being times by the number in front. Now, as far as sine and cosine goes, when we get into the trig functions, of course, we'll get into the other ones later. But for sine and cosine, they're really just derivatives of each other. So derivative of sine is cosine, but the derivative of cosine goes to a negative sign. So that's key there. Going from cosine to sine, it switches signs. So y equals 2 sine of x. Well, the 2 is a multiple, so it's going to stay the same. So y prime would equal 2. Sine then would go to cosine, so 2 cosine x is its derivative. Now here, y prime would equal, well, x is a separate term. We're not a multiple like the 2 was, so derivative of x would just go to 1, because 1 is the exponent, so 1 would come down, and we'd left with x to the 0, so we'd have 1 there. Now, cosine goes to a negative sign, so this plus will change to a minus sine of x. So, derivative of cosine is a negative sign, derivative of sine goes to cosine. So sine to cosine stays positive, cosine to sine, it's going to switch to sine. The next part of this, rates of change. Remember, it's just distance over time is the rate of change. How far are you going for the amount of time you're doing? So that's really the same thing as average velocity. We're just changing our distance and our change of time. So change of s over change of t. So average velocity is what we've done for forever. So we're going to do a problem here, and then we're going to show you how we can find this a different way. So if a billiard ball is dropped from a height of 100 feet, its height s at the time t is given by the position function s of t equals negative 16t squared plus 100, where s is measured in feet and t is measured in seconds. Find the average velocity over each of the following time intervals. So s of t is your position. So how is the position changing versus the time? So if our time's going from 1 to 2, when we set this first part up, time always goes on the bottom. So 2 minus 1. So if we put 2 in here, 2 squared is 4. 4 times the negative 16 is what? Negative 64? Yes, negative 64 plus 100 would leave us with 36 on top for the 2. Oop, I should put this over here, 36. Because then we're going to minus when we put 1 in there. 1 squared is 1, so negative 16 times 1 is still negative 16. 100 minus 16 leaves us with 84. So 36 minus 84 leaves us with a negative 48. 2 minus 1 is over 1, so we're going to end up with negative 48 feet per second. So distance over time, feet per second. So now we're going to do 1 and 1.5. So again, bottom, 1.5 minus our 1. So when we put 1.5 in here, what do we get? Well, 1.5 squared. 1.5 squared equals 2.25 times a negative 16 is negative 36. So if we add 100 to it, we end up with 64. Well, we already put 1 in, we got 84 out. So 64 minus 84 is a minus 20. We're 0.5 on the bottom. So negative 20 divided by 0.5 is going to be a negative 40 feet per second. See now, 1.1. So bottom, again, 1.1 minus 1. We're minusing our 2 times. Tops, though. Well, 1.1 squared leaves us with 1.21. If I take that times a negative 16, I get negative 19.36. If I add 100, 80.64. Or minus 84, because then we're dealing with 1. We already found those on these other ones. So when you subtract those, you get a negative 3.36 over a 0.1. So this moves once, this moves once. We end up with negative 33.6 feet per second. So makes sense, because if we're dropping a billiard ball from 100 feet, gravity is going to pull it down and speed it up. It's going to be accelerated. So going from 1 to 2 should have a faster speed compared to if we go from 1 to 1.5, because we're still accelerating for an extra half a second to get up to the negative 48. Here again, we're a tenth of a second difference, so that tenth of a second should be a little bit slower than what it was if we're 4 tenths faster or even 9 tenths faster. Okay. Now, what's nice about this, to find our actual velocity, to find instant velocity, all we gotta do is find the derivative of our position function. And it's the same idea with acceleration. The derivative of the velocity will give us our acceleration. So as far as position goes, a lot of times you're going to start with this. It's a half of gravity times squared plus the initial velocity times time plus the initial position. So if you've taken science classes, you'll know that gravity is either 9.8 meters per second squared or negative 32 feet per second squared. Again, v naught initial velocity, s naught initial position. So in other words, your height that you're starting at. So at t equals 0, a diver jumps off a diving board that is 32 feet above the water. The position of the diver is given by s of t equals negative 16t squared plus 16t plus 32. So the 32 is our initial height. 16 must be our initial velocity of what he's jumping off the board with. And so they're using negative 32 for the g. So half of negative 32 is negative 16. That's where they're getting that from. So when does the diver hit the water? Well, the diver's going to hit the water when our position is 0. Our height is 0. So we're going to do s of 0. No, that's what t, hold on that. Not s of 0, but s of t is going to equal 0. So 0 would equal negative 16t squared plus 16t plus 32. So we're going to factor this. First thing we're going to do is we're going to pull a common factor of negative 16 out. So 0 would equal negative 16. Inside here would be t squared minus t minus 2. A lot easier to factor out from there. So we could divide this negative 16 over. 0 divided by negative 16 is still 0. So we can really drop that part. So this is going to go to two sets of t's. So t and t. Factors of negative 2 are 2 and 1. So we're going to have a plus 1 and a minus 2 because our middle number is negative. So if we solve for this, t would equal negative 1 and 2. Now, could we have a negative time? Well, no, we can't hit the water before we jump. So the other one would be 2 seconds. And that is part A. Part B now is, what is the diver's velocity when he hits the water? Well, we know this is going to happen at 2 seconds. To get our velocity, we're going to find the derivative of this function. So s prime of t, which is going to be our v of t function, our velocity function. So derivative of negative 16t squared, bring the 2 in front. 2 times negative 16 is negative 32. T squared, 2 minus 1 would just be a t. 16 is just going to stay at 16 because t to the first times, so 1 times 16 is that. 1 minus 1 is t to 0. And our 32 is gone because derivative of any constant is 0. So for 2 seconds, we're going to do v of 2. So negative 32 times 2 plus 16. Negative 32 times 2 is negative 64 plus your 16. We'd end up with a negative 48. And this is velocity, so feet per second. And that's it. It's so much easier doing it that way than the long way. But again, want you to appreciate this shortcut way and really to understand how they're getting there. They're doing that big long process. And again, they found an easier way to do it. So that's why we're doing this now and not to begin with. So if you have any questions, let me know. Otherwise, talk to you later.